Hello everyone. We are discussing vectors and we have almost completed the basic part of vectors, which is how to express something in terms of I cap and j cap, how to resolve a vector, how to add a vector, how to decode a vector. All these things we have done so far, and therefore we'll continue the kinematics part where we had we started from concept of distance and displacement and all those things. Now, for displacement type of vector, we develop the whole thing. Distance and displacement, we have done these things. Next comes, this is the continuation of kinematics, remember. Next thing which we need is speed. Write down the heading, speed. And write down the statement. Rate of change of distance, rate of change of distance with respect to time, rate of change of distance with respect to time is called speed. Rate of change of distance with respect to time is called speed. Write down properties of speed. Properties of speed. Number one, and before I provide information of the first property, let me ask you, what type of quantity speed is? Is it a scalar quantity or a vector quantity? What do you think? Write down in the comment box if you have a little bit of idea of speed and all from 9th and 10th. What type of quantity speed is? Is it a scalar quantity or is it a vector quantity? Mention this thing in the comment box. Write down the statement. Speed is a scalar quantity. Speed is a scalar quantity. That means when speed of an object is given, that means when speed of an object is provided, we cannot get any information of direction from it. We cannot get any information of direction from it. It's like saying this, if I say that speed of an object is 20 meters per second. Once you say that there is a bike which is moving with 20 meters per second, that's all. You get the information of what? A number, a magnitude. You have no idea regarding the direction. Direction means where that bike is traveling to. Is it moving east, north, west, or whatever direction? That is something which we will develop in velocity. The first property says that speed is a scalar quantity, which means it has no information of direction. Write down the second one. Once I say that speed is a scalar quantity, second statement automatically tells us that it should be a positive quantity. Because positive and negative, if you define separately, they give you the information of direction. We cannot get that information of direction, and therefore speed is always what? Positive, just as a number. It's always 20, 30, 40. It's never minus 40. Right, now the second property. Since speed is a scalar quantity, since speed is a scalar quantity, it is always positive. Since speed is a scalar quantity, it is always positive. Now, up to this point, you will find that these things are similar to the distance. Distance also was scalar. Distance was always positive. And if you remember, in distance I had told you that distance is something which never decreases. If you are moving, distance is increasing. If you turn back, it is still increasing. This is something which we have already discussed. So, distance is something which always increases. What is speed? Rate of change of distance. So now my question is, can we say that speed is also something which never decreases? Can I make a statement like this? What do you think? Yes or no? Mention in the comment box. Can I make a statement like this, that speed, since is rate of change of distance and distance never decreases, can I say that speed also never decreases? What do you think? Yes or no? It's plain logic. It's common sense basically what I'm asking you. Good. Everybody answered correctly. Speed can increase or decrease, or it can remain constant. It's like this. You started your bike, you accelerated, speed is increasing. You apply brakes, and then speed starts decreasing. There is no restriction on speed regarding increase or decrease. But sometimes people get confused because it's coming from distance, and therefore we'll write point. Write down third point. Speed can increase comma, remain constant, or can also decrease with time. It can also decrease with time. Now write down the next point. The next point is the elementary point. What is the unit of speed? Unit of speed is, write down the point, unit of speed is meters per second. Very basic knowledge. Unit of speed is meters per second. Now again, the next point is dimensional formula. Write down the dimensional formula of speed in the comment box. Dimensional formula of speed, write it down in the comment box. Again, something which is very elementary, and you can do that. And those who have no idea of dimensional formula, look here. Unit is meters per second. Meter is length, L. Meter means what? Length. Second is time. Second is what? Time. We write this in this form. L t to the power minus 1. We will shift t above like this, minus 1. Capital M stands for mass. It's not for meter. What is small m? Length. What is capital M? Mass. There is no term of mass in speed. No means 0. Inside the square brackets, this is called dimensional formula of speed. 0, 1, minus 1. Write down this. Remember, those of you who only provided L t minus 1, your answer is correct, but this is how you will present it if they ask this question in school examination. Mass 0, L t minus 1. Now continue with the last property. Dimensional formula is this, and its dimensions are these powers. What is power of L? 1. When you write like this, inside small brackets, 0, it means there is no mass. Length is 1. Time is minus 1. These numbers, they are called simply what? Dimensions in the dimensional formula. Dimensional formula of speed is, and its dimensions are 0, 1, minus 1. Now this is all very easy and elementary information, nothing special in it. Now, this is what properties of speed and all. Now let's define speed with the help of graphs. So if I plot a graph like this, V for speed, small t for time. On vertical axis I am plotting V, on the horizontal axis I am plotting time. And if I say that I have a graph like this, and these are different segments of this graph: A, B, C, D, E, F, G. Considering all the properties, if I ask you which segments are correct, out of all these segments which I have shown, in the comment box mention that these are the sections which are correct if you plot a graph of speed versus time. Note down the graph and answer the question. Look here, left side portion. In this portion, first of all, time is negative. T is negative. Horizontal axis is time. This is like 10 seconds, 9 seconds, 3 seconds, 0, -1, -2. We cannot have negative time. At the same time, you can see that V is also coming negative. This is positive. This is 20 meters per second, 10 meters per second, 4 meters per second. This is -8. And since speed cannot be negative, in time, we say that this portion of graph is not correct. Over here, in this graph, your time is positive, but since you are below the horizontal axis, you again have your V negative. Speed cannot be negative. It's a scalar quantity, and therefore this portion is also not correct. There is nothing wrong about C. Everything is correct. Speed is positive. It is increasing. There is nothing wrong about D. Speed is positive and is constant. It means speed is what? Constant. From this point to this point. Speed is decreasing. When a graph goes down, that means speed is decreasing. Speed can easily decrease. Nothing is wrong. F. Speed is again increasing. Nothing is wrong. Last part. The last part, speed is positive. It is increasing. But there is a problem. In the last part, your time starts decreasing as you go back in time. Something which is not possible. And therefore, since time is decreasing, we say that graph like G is not possible. What are the correct answers? C, D, E, F. All the properties regarding scalar, positive, increasing, decreasing, they can all be explained or understood with the help of this single graph. Mention everything like this. This portion is not valid because time is negative, velocity is negative. This portion is not valid because velocity is negative. And the last portion is not valid because time is decreasing. Note down this much. This last part, it tells us what? That suppose this time is 10 seconds. If I say that that's how you have plotted the graph. If this is 10 seconds and suppose this point coincides with this one along the vertical axis, and Let's say this is 8 seconds. Remember, your graph is running like the blue curve. The blue curve which you see is a graph, and the vertical sections in black, they represent corresponding time. What you are saying, at 8 seconds, your velocity is 0. Velocity is decreasing, it becomes 0 when time is 8. It increases up to 10 seconds, and then graph says it further increases, but your time goes back to 8 seconds. So, a graph in which time starts decreasing is never allowed. Time is increasing, time is increasing, time is increasing as long as you are moving along this direction. What is this? This is the time axis. Your time must always increase. You are moving, you're not moving, you are interested in speed or not, doesn't matter. Time is something which always increases, but this portion says your time starts decreasing from 10 to 8. That is something which is not possible. Or you can produce another argument. You can also produce another argument like this. Suppose somebody gave us a graph in this form, then this is your v-axis, and right here it's written that 25 meters per second. What is this? 25. What does it mean? It means when time is 8 seconds, if you follow this graph, then speed is what? 25. But if somebody looks at this portion of the graph, at 8 seconds, this portion of the graph says speed is what? 0. Origin. So, if you draw a graph like this, which is going back, then there is a problem. At 8 seconds, if I ask you, what is the speed of the object? Then there are two answers. One is what? 0, and the other one is what? 25 meters per second. It's like that. If I ask you, at a given time, a bike is moving with 0, and it is also moving with 25 meters per second. Both things cannot be true, both things cannot be correct simultaneously, and therefore a graph like this is not possible. Hope you understand why the last portion G was not correct. Now, once we have defined properties and we have understood graph of speed versus time, write down the next thing, not the point, it's not the property, write down the next line. Speed is defined in two ways. Speed of an object is defined in two ways. Number one is instantaneous speed. Instantaneous speed. Number two, average speed. Write down like this. Speed is defined in two ways. Number one, instantaneous. And number two, average speed. Now let's understand these parts in detail. Right? Let's define instantaneous first. Write down the instantaneous speed. Speed of an object. Speed of an object at a given instant. Speed of an object at a given instant is called instantaneous speed. Speed of an object at a given instant is called instantaneous speed. Now, what is instantaneous? Suppose you are inside a car and car is moving with increasing speed. So, car starts, let's say, with 0. Speed increases, becomes 20. After some time, speed increases, becomes 30, 40, 50, and so on. Somebody who was inside the car, what he does, he at different times take a photograph of the speedometer, and what he found that the photograph which he took at t equals to 0 was showing speed as 0. Next, let's say he took a photograph when time was 5 seconds, and in that photograph he found that speed of the car is 20 kilometers per hour. Normally in car, you know that speed is given in terms of kilometers per hour, and therefore I have taken this unit. You can always take meters per second, doesn't matter. Next, he took a photograph when time was, say, 7 seconds, and speed was coming, let's say, 35 kilometers per hour. So what is t equals to 5 seconds? It is an instant. At that instant, when you took the photograph of the speedometer, you could see 20 kilometers per hour. This will be called what? Instantaneous speed when time is 5 seconds. The next photograph you saw, it says what? When time is 7 seconds, speed is what? 35 kilometers per hour. This 35 is the instantaneous speed when time is what? 7 seconds. Speed at a given instant is called what? Instantaneous. Draw this information and then we'll write a few points. Write down the statement. For the given data, instantaneous speed at 5 seconds is 20 kilometers per hour. Although the whole thing is clear, but still we are writing the statement so that later on when you revise, you understand the whole part easily. Similarly, instantaneous speed when time is 7 seconds, instantaneous speed when time is 7 seconds is 35 kilometers per hour. Now comes the conceptual part. Normally you have seen the formula of you all have seen this formula of speed. Everybody knows about this. Distance divided by time. Meters per second. Speed is what? Distance upon time. There is a problem with this. This formula is not valid always. Let's see if you have the idea, if somebody has the idea, if you have seen this type of thing before. Let me ask you, do you have the idea of when to use this formula? When is this formula valid? Is it always valid or there is some restriction on it? That's what my question is. And this is something which is going to explain instantaneous later on. So my question, and if somebody can answer, then tell me the reason, tell me the condition when one must use speed as distance upon time. It seems nobody has the idea. Don't you worry. Don't you worry. That's why somebody is asking that why do we need speed when we have defined this thing at a particular instant? Just to understand all this, why are we taking first instantaneous, second average? Just give it some time and you will understand these things one by one. First of all, write down speed equals to distance upon time. And for speed equals to distance upon time, I will plot something here. Look at this data and then you will understand what I am trying to teach you. Everybody, look here. So this is the starting point A. An object is moving from A to B, then from B to C. And say between A and B, speed was 10 meters per second. Between A and B, speed is what? 10 meters per second. And it moves for 2 seconds. Just look at the data. Don't have to note down anything. Look here. Between A and B, an object is traveling such that speed is what? 10, and it takes 2 seconds. How much distance will it travel? You will use this formula. Distance is what? Speed into time. Everybody knows that this object is going to travel 20 meters. 10 into 2. Nothing special about it. Then, from B to C, object is moving with 30 meters per second. Between B and C, the object is moving with 30 meters per second, and it moves for 3 seconds between B and C. What is the distance it travels? B and C, what is the distance it travels? You will simply say distance is speed into time. Speed into time is what? 30 into 3, 90 meters. I hope so far there is no confusion, there is no problem at all. We were given this information of 10 meters per second. Object is traveling for 2 seconds. Distance it travels, something which we already know from 9th and 10th. Speed, time, distance. Now, look here. If I tell you that an object is moving from A to C, an object is moving from A to C, a total of 20 plus 90, 110 meters. I hope you can see it. 20 plus 90, 110 meters. In what time? A to B, 2 seconds. B to C, 3 seconds. What is the total time? Total time is what? 5 seconds. A distance of 110, a total time of 5 seconds. And then if I ask you, what is speed? And you start using this formula, which says distance upon time. Distance divided by time. 110 divided by time. Speed is coming what? 22 meters per second. Now look at this 22 meters per second. A distance of 110, which was covered in 5 seconds. Somebody uses this formula of distance upon time, and he says that object is moving with a speed of 22 meters per second. But look at the data. This object, this car, was never ever moving with 22 meters per second. It was moving with what? 10. It was moving with what? 30. It was never moving with 22 meters per second, and therefore something definitely went wrong when I was using this formula of distance upon time. Now, what went wrong is a one-line statement. This formula is used only if speed throughout is constant. It's a very important statement. it will teach us another mathematical tool which is required in physics, and that is called differentiation. Something extremely important is differentiation. So just don't worry right now. The thing is, you can see that speed of 22 is never ever present in the data, in the actual data. Why this whole thing went wrong? Because we are using a formula which demands that it must be used only if speed is constant. If you understand why this thing went wrong based on this example, then write down yes in the comment box, and also note down this as well as this, make a cross, and then we'll write few statements. If you do not understand, then do not hesitate. Write down no, ask your question, and I'll make all these things clear again. Write down the statement. Speed equals to distance upon time. Speed equals to distance upon time is used only if speed is constant throughout the distance. Speed equals to distance upon time is used only if speed is constant throughout the distance. Between A and C, as speed is not constant, between A and C, as speed is not constant, we cannot use write down equation number 1. Again and again repeating the same thing. Between A and C, since speed is not constant, we cannot use this formula or equation number 1. Now, let me ask you this question in this form now. I'm holding this marker And if I drop this marker, as I drop it, can I use equation number 1? If I need to measure speed when I drop this marker, then my question is, can I use equation number 1? What do you think? Yes or no? Write down fast in the comment box. I hope you all have answered no, because you can see that when you drop something under gravity, then it is going to definitely increase its speed. As it comes down, speed is increasing because of gravity, and everybody knows that gravitational acceleration of 9.8 meters per second square, something you must have heard of. So, when I drop this marker, I cannot use this formula. Speed equals to distance upon time. Therefore, question is, for a situation like this, in which speed is continuously changing, increasing or decreasing doesn't matter. If I throw the marker up, as it goes up, speed decreases. As it comes down, speed increases. I cannot use that given equation. Speed equals to distance upon time. What should then be done? How can we find speed of the object? That's what is required or is meant by instantaneous speed. Now, instantaneous speed, we mathematically is defined as dx upon dt. Just don't worry, these numbers, they will be clear in a few seconds. V is dx upon dt. What is V? This V is instantaneous speed. In fact, write down like this: instantaneous speed at time t. Instantaneous speed at time t is V is dx. How do you read it? Dx. What is dx? We'll see that. Dx divided by dt. Dx divided by dt. What is this dx divided by dt? This is called rate of change of x. Rate of, write down this, dx upon dt is called rate of change of x. Rate of change of x with respect to rate of change of distance x, right? Make it like this: rate of change of distance x with respect to time t. Rate of change of distance x with respect to time t. Now, what is rate of change? You already know. That's how speed is defined. How do you define speed? Rate of change of distance with respect to time. This is not something which is spatial. Next part is spatial. This is something which you already know. I gave you this information so that the thing which you write next, you can correlate with that easily. What is dx by dt? Rate of change of distance x with respect to time t. Now, this is also called differentiation. Differentiation of x with respect to t. Just to separate t and t. What is this dx upon dt called? Differentiation of x with respect to t. What is differentiation? Just hold on, things will be clear. But as of now, write down these two things. Just don't worry, the very elementary things, the very elementary formulas for this, and we'll also go deep. But as of now, rate of change of distance and rate of change of the other thing is the same thing is called differentiation of x with respect to t. Just to make ourselves feel comfortable with this terminology, as a side note, if they are written like this, dy upon dx, dy upon dx. What is y? We have no idea. What is x? We have no idea. But somebody has written dy upon dx. Then we'll call it what? This is differentiation of y with respect to x. What is dy upon dx? We'll call it differentiation of y with respect to x. What is y? What is x? We have no idea. The way you read it, the way you read something like this is differentiation of y with respect to x. What basically is this? What basically it is rate of change of y with respect to x. Rate of change of the numerator with respect to denominator. So also write down with this and write down the whole thing. Rate of change of y with respect to x. Rate of change of y with respect to x. Now let me ask you this. V for velocity, T for time. V for velocity, T for time. Then just let me see if I have told you this much about differentiation. Can you answer what basically this thing is? What is dv upon dt? Can you answer this thing? Then write down in the comment box what basically this is. This is something which you already know. This is something which you already know. First of all, if v is velocity, t is time, then we'll call it what? Rate of change of velocity with respect to time. Have you heard something like this before? rate of change of velocity with respect to time. You have the idea of dv upon dt, that this is something which starts with a. I hope you understand now what is a. Good. A few of you have answered this thing. So, what is dv by dt? This is called acceleration. What is dv by dt? Acceleration. Now, you are comfortable with this term, acceleration. You are comfortable with this term. In 11th, this acceleration is written like this: dv upon dt. What is dv upon dt? The way you read this thing. This dv upon dt is rate of change of velocity with respect to time, or we'll call it differentiation of velocity with respect to time. So far, I'm concentrating on the way you define differentiation. How do you represent differentiation? That's what I'm explaining in all this, and then we'll go deep and understand how to perform differentiation. Right now, note down this dv by dt. Write down this is acceleration, and then make another equal sign. Make another equal sign. Write down rate of change of velocity with respect to time. Rate of change of velocity with respect to time. Make another equal sign. Make another equal sign. This is also called what? Differentiation of v with respect to t. Differentiation of v with respect to t. Well, I hope you understand this much. The way this differentiation type of thing is read. dv upon dt is what? Acceleration. Let me again ask you. I hope you know this thing. If W stands for work, W, and T stands for time, then what do you mean by dw by dt? I'm not asking differentiation of W. What do you mean by dw by dt? You're trying to feel comfortable with these things first. If W stands for work and T stands for time, then let me see if you can answer this thing. Very good. This dw by dt is something which you call what? Power. Write down like this: power, and then again rate of change of work with respect to time. First write down power, then write down rate of change of work with respect to time, and then again write down, make another equal sign, and then write down differentiation of work with respect to time. Differentiation of work with respect to time. So nothing special. This is something which is coming from 9th and 10th only. You know what power, you know about acceleration and all. but the presentation is slightly different. And why do we go for these slight changes? This is something we are interested in. I hope so far things written on the board, they are clear. And now we'll start defining V and the meaning of dx and dt. Now regarding complete information of differentiation, I will give you a separate lecture, a recorded lecture, because that much detail is not required. So those who are interested in deep understanding of differentiation, those of you, they will send a request over WhatsApp, and then I will give you that detailed lecture. Right now, we are interested in the meaning of differentiation. So after the class, those of you who are interested, simply send a WhatsApp request and I'll give it to you. If you do not send it, there is no worry. This is something which you must know. Pay attention. Now, we have an object. Does not go down anything. Look at the board. There is an object. It starts from A. At A, we found that its speed is 1 meters per second. It reaches somewhere here. B, speed becomes 2 meters per second. Gradually, speed is increasing. It reaches C, speed becomes 3 meters per second. That's how speed is increasing gradually. A, 1 meter per second. B, 2 meters per second. C, 3 meters per second. A situation like this, as if somebody has dropped this vertical part and defined in the horizontal direction. Or you have a bike which is speeding up 1, 2, 3 and so on. Point is, for this object, for this path, speed equals to distance divided by time is not valid. I cannot use this formula. Formula says it should be used only when speed is constant, which it is not. And therefore, what we found is this. If I say that speed at this point is 3, then somewhere at this point, before C, it will be roughly 2.8. Speed is gradually increasing. At C, it becomes what? 3. Somewhere before C, it will be definitely what? 2.8. At this point, let's say it was 2.3. At this point, it was 2.1. At this point, it was 2.01. At this point, it was 0.001. The argument is I hope you can see it. The argument is as you come closer to this point B, your speed is coming closer to this number 2. Again, speed is gradually increasing from 1, it becomes 2, becomes 3. So somewhere here, we are saying that it will be roughly 2.8. A bit closer, 2.3, a bit closer, 2.1. At this point, 2.01. At this point, 2.001. Just random numbers. And then, somebody says, try to reach further close to point B. Let's say we went for this point. I hope you can see up to this separation. At this point, speed is what? 2.0000001. I hope you can understand that if I try to reach as close to B as possible, my speed will also come closer to this number 2. Look at this 2.001. If I go further close to B, it will become what? 2 thousands of zeros and then 1. If I go further again close to B, that number of zeros will further increase. Now, before I proceed further, do you understand this argument of coming close to this number 2 as I have shown in this figure as I approach B? Do you understand this? Mention yes or no in the comment box first. This is something which is important. Without it, there will be no way I can explain differentiation. I am using a very straightforward, simple argument. Good. It's like this, that if somebody reaches close to this point A, and if you're very close to A, your speed will be roughly 1.0000001. As close as you reach, it will be almost 1 only. Now, with the help of this, we are going to understand meaning of differentiation. So let me draw this B over here. I've drawn a line. Left end of this line is B. This point is B. And at B, you know that speed is what? 2 meters per second. Now, as I come closer, what basically I am doing is this. Try to decrease this length. Try to decrease this length and try to reach as close to B as possible. As close to B as possible. If I keep on decreasing this length, if I keep on decreasing this length, if I keep on decreasing this length, now let's say it becomes 1 millimeter. You keep on further decreasing this length, now it becomes, let's say, 1 nanometer, 10 to the power minus 9, further small. It becomes further small, let's say the size of an electron. If somehow you can divide that electron, something which is not possible, that's a different thing. But suppose you could, as small as possible, as close as possible to B if you can reach. That's what the aim is. Now, since it's not possible to show that type of small distance, what we do, we say that this point is B, Now remember, this point is the next point after B. If I draw something like this, an electron size, then it will not be visible. So remember, this second point, if I call it B dash, what is B dash? B dash is the closest point to B. Then B to B, this distance in physics is called what? Dx. What is dx? Dx means very, very, very small distance. Again, just so that you can see it, I have drawn BV dash like this. Otherwise, I told you what BV dash is. Draw a line and keep on decreasing it. Keep on decreasing it. As small as you can draw it. As small as you can draw it. You cannot even see, you cannot even see this dot over the board. And therefore, what I am saying is, let's say you can see this much length. This left end is what? B, and the rightmost end is what? B dash. But this B dash, remember, is very close to B. How close? We have a term in maths which says, call this very, very, very small distance, what? Dx. This dx is something which is not zero. Remember, it's a very, very small distance, but it is not zero. This dx is approximately, this is a sign of approximately 0. What is the meaning of dx? Dx means a very, very small distance, which is not 0, but is almost 0. Put on this, put on this. I will take 5 minutes more, just hold on. Now the argument is, this is dx. What is dx? Something which is very, very small. Now, when the object was moving from A, passed through B, reached C, and so on, from B to B, distance which was travelled was dx. And time from B to B dash, we are saying is dt. Since it's a very small distance, to cover this small distance, time taken will also be what? Something which is very, very small. So what is dt? Dt we call is very, very, very small time. Just like dx is what? Very, very small. D means very, very small time. D means very, very small distance. So from B to B dash, we have a small distance of dx and a very small time which object took to cover this distance, that is dt. Now look here. Just so that you can see it clearly, this is your B and this is your B dash. This length, remember, is even smaller than the length of an electron. At B, speed is what? 2. At B, speed is what? 2. At B dash, speed is what? 2.000000000001. As many zeros as you can put. As many zeros as you can put. When we are at this position, we have these many zeros. Come further close to B. As you approach B, you are simply increasing these zeros and then 1. As you approach, you are saying that billions of zeros and then 1. The next person comes and says that I will go further close to B. There is no issue. 2 billions of zeros, then billions of zeros, and then put 1. There is no limit to reach close to B. And therefore we say that, simply call it distance of a small distance of dx is present between B and B. We are as close to B as possible, and that distance is what? Dx. Now, at B, what is the speed? 2. At B dash, what is the speed? 2 point, how many zeros? Billions and billions zeros and 1. I hope you can see that this is approximately 2 only. 2 billions of zeros and 1 is almost what? 2. That's the beauty. What is the beauty? This speed formula, distance upon time, it says you can use it only if speed is constant. From A to B, from B to C, speed is changing from 1 to 2 to 3. I cannot use this formula. But from B to B dash, there is hardly any change in the speed. That means from B to B dash, speed is what? Almost constant. If speed is constant, then how much distance is present? Dx. In what time did you cover it? Dt. How do you define speed? V. What is the speed? Distance upon time. What is distance? Dx. What is time? Dt. Can I use this formula? Yes. Why? Because for distance dx, there is no change in the speed of the object. If you understand reasoning behind dx upon dt, then write down yours in the comment box. Good. Now, further in detail, we'll understand differentiation in the next class. And as I told you, those who need extra information, they must simply request, and I will give you the detailed lecture. Otherwise, in the next class, we'll again briefly discuss dx by dt, and then we'll establish simple formulas for that. I hope you understand this lecture. If you want to see this lecture again to understand these parts in detail, you can also send requests for this particular lecture. Thank you very much.